Welcome to the last of our three-part series on how to go about creating buffer overflow exploits and how to turn them into something you can use with Metasploit. So far, we've talked about how to discover the vulnerability. We've taken a look at how to actually create some shell code. We've even gone through some manual exploitation just to demonstrate that we have a working proof of concept. Once we've got all of that information and we keep track of the different memory values, where we are as a return address, how much space we have on the buffer, once we've got that data, we're ready to turn this into something we can take into Metasploit. Let's see how we can do that now. With that working proof of concept, it's useful to take some stock and keep track, maybe some notes, of what information you've learned. For instance, remember, we've got a 124-byte buffer to work with. We know that. We've got a stack address. We know perhaps what a return pointer is going to turn out to be. We know that we're able to control the instruction pointer because we're overriding the return pointer on the stack. With some of this information, we're now ready to walk over to Metasploit and implement that into an exploit plugin. To do so, it is good to have some basic knowledge of Ruby, but it's really not very necessary unless you've got more advanced problems to deal with. For instance, if there are some variety of protections that may be found, you may have to write a little bit more code. But in our case, we essentially are just going to do some fill in the blank. Metasploit comes with a sort of a skeleton plugin that you can find in the development directories. We've taken that and we've modified it a little bit, and we've actually created some comments in here too, so you can see what's happening in the actual exploit. Unfortunately, as much as I like Metasploit, and I really do like Ruby, I find that many of the Ruby projects that are out there require you to know some sort of secret sauce or magic recipes to get things to happen. And unfortunately, Metasploit is no real exception here. While the tool itself is well documented, the creation of exploits is not very well documented at all. So you might use this as a framework of how you can go about creating an exploit for a TCP-based service. So let's just walk through this quickly. Notice that we're requiring, first of all, the MSF core so that we can make use of all of the functions that are built in. And next, we're creating a Metasploit 3 class for a remote exploit. And we're including for that the TCP services for those remote exploits. That's going to be the same for almost any TCP-based exploit that you're going to create. The next piece, too, is going to be more or less the same, though some of the values within it will change. Again, you'll find that this piece, beginning with the def initialize, all exists inside of the skeleton framework that comes with it. This here is actually a little bit of secret sauce just to get things started, but then here we've got initializing the information into the information mapping. So we set a name for a course example, and then we've put some quoted text. That's what this %q with the bracket and a closing bracket. This is just some quoted text to describe the exploit itself, information about the author and the version, and this is information about the payload. Now here's where we start to get to important things. When we're talking about the payload, we have to define how much space we have to work with. So you'll see a number here that looks very familiar. 124 was the size of our buffer. And we're then asked to list any bad characters. Now there actually are some bad characters, probably a null is a bad character, but I didn't bother putting any in here. Now we have any default options that need to be set, got that listed up here, and any other things. So here for the default options, I'm setting the R port, the remote port, to be 7777, because I know that for this sample service, that's where that service is going to be. You don't have to set that, but it saves the amount of typing that someone using the exploit module has to use. We then have some definitions of targets that are available. Now my target service is only available for Linux, so I give a little bit of information about it. I put it on the Lin platform, and then I can define a return address. Remember, we discovered that there were no protections in use in this particular flaw. So this return address is the location on the stack that we begin controlling. Now, this is, as it says here in my comment, we are cutting it super close. In other words, we are using the entire thing. We're giving Metasploit the whole thing. It might be better to make it more reliable, to reduce this number down. So in other words, we would change the return value to be something further up in the stack, and then reduce the amount of space that we're reporting to Metasploit is available. But for this particular case, it's just a trial. This will work just fine every time. We then can define other things like the default target, which is Linux, and that's the only target. So that's pretty much it for all of our default options. Now we're ready to take a look at the actual exploit. Now, the check function can be used to create some code to test to see whether or not a particular application is vulnerable. We're not implementing anything that does that. So we're simply going to return essentially a true. We're going to return, yes, it's vulnerable, every time. This can be used for testing mechanisms because remember, Metasploit has the ability not just to exploit, but also to test to see if you are vulnerable. You could write a more complex test here, but we're more interested in how to write the exploit, not in how to write the testing. Next, at the bottom, we've got the actual exploit code. So with all of our definitions already made, we now just have to tell Metasploit how to go about using the information. The first thing we tell it to do is to connect to the remote host on the remote port, and then to begin building a buffer. What we're going to ask the buffer to do is build out an encoded payload. So whatever payload is selected by the person running Metasploit, we're going to encode that into the buffer, and then we're going to add on the return address. With that done, we're going to put it out and then grab anything that comes back and hand it off to the payload handler. And if you notice, that's it. So Metasploit really is a very, very simple way to go about writing exploits, because here, with just filling in a few values, tinkering a little bit, and putting our file in the proper directory, we can now launch an exploit any payload that Metasploit has that fits into the destination space.